In this video, we are going to learn about plotting, since we are going to plot this Fibonacci sequence. The Fibonacci sequence is as follows. The third number is the sum of the first two numbers. From there, each last two numbers get added up to become the new final number in the sequence. Basically, it's a long vector that keeps extending itself and can be described by the following formula. We have already seen plenty of these kind of exercises in MATLAB, so let's try. So let's open a new MATLAB file. We are going to write a script, and we can start this with close all, since we are going to plot that closes all figures, and clear all. Then define the vector f. This is the vector that is going to keep extending itself. It's an empty vector now. And n is 50 is the amount of calculations we are going to make. Now we can write the for loop for I is 1 until n. So for all the calculations we are going to make. And close it with an end, and then write the formula for the Fibonacci sequence between there. I hope that by now you're trained enough to be screaming at your screen that I'm doing this wrong. Because see, we are currently indexing outside our vector. That is not possible, right? We index 2 places back. So that means that we have to start at n is 3. And how do we define the first numbers then? Well, that's simple. We just fill them already in because we know them. Now let's run the script in debugger mode. This is a perfect way to see if your loop is working, since it shows the steps MATLAB is taking. And if we run it, we indeed see the Fibonacci sequence growing, the f vector becoming longer and being extended with the numbers of the Fibonacci sequence. So it looks like this script works. So now we are ready to start plotting. As always in plotting, you need 2 data sets. So we need a vector n that we can plot our Fibonacci sequence against. We can easily define this data set by making a vector of x values, which goes from 0 to n. So now we have 2 data sets that we can plot against each other, x and f, and we can plot them in MATLAB by just typing plot and then x and f between parentheses. And we can maybe try to plot a nice dotted line by using the dot. And if we run this, we don't get a plot. There's still an error. It says vectors must be the same length. So apparently x and f are not the same length. Let's inspect this a little more in detail. Let's use the debugger, and then we can see how long the vectors are. F is indeed 50 long, but x is 51. And this is because x is running from 0 to n, but it's counting 0 also as a number, so it's actually 51 long. Therefore, we have to extend f a little to make them the same length again. We can just make f from 3 to 51 instead. Now, both vectors should have the same length, so we can try to plot and see if this indeed works. Now let's try to see if we can plot it. So let's run the script. And indeed, we do get a nice plot. Let's make it a little more nicer by adding a title, for example, and axis labels. Title can just be done by title and then your title between parentheses. Make sure it's a string. And labels can be given by using X label and Y labels. Also be careful here that you use strings there. Once we plot this, we already get a much nicer plot, which has a title and an axis label. However, you cannot really read the data because the Fibonacci sequence is increasing exponentially. So in order to make a better plot, we can maybe use a logarithmic plot because we have an exponential increase. Since only the Fibonacci sequence is exponential, but the data set on the x-axis is not, we only have to use a plot which has a logarithmic y-axis. If we can find one of those, it would be great. So as we did before, let's look into the MATLAB help desk to see if we can maybe find a type of plot which has a logarithmic y-axis. So let's click MATLAB as we did before. And now we're not going to language fundamentals, but to graphics, since we are plotting. In graphics, we go to 2D plots because that's what we're making. And then under line plots, we already see log, and semi-log. That's logarithmic plots. We already find logarithmic, and there it is. A semi-logarithmic plot, a semi-log y, sounds like a semi-logarithmic plot on the y-axis. Indeed, we see that this function plots data with logarithmic scale for the y-axis. So let's use that one. It works exactly the same as the normal plot function, only instead of plot, you say semi-log y. Then we can open a new figure by just typing figure so we can see both of them. And when we now run it, we see that this figure is much clearer than the old one. So now we know how to plot, how to add titles and axis labels to your plots, and also how to plot logarithmic plots, which is especially important in microbiology, since microorganisms usually have exponential growth, and then an exponential plot can help a lot.